Today we're starting our new chapter, chapter 3. We're going to be working on exponential functions and logarithmic functions throughout the chapter. And exponential and logarithmic functions are inverses of each other, which switch that domain and range. And that's why we need to have them. We need to be able to solve for a variable when it's in either place, so we'll switch back and forth between those things. Okay, the definition of an exponential function is f of x equals a to the x. Where's the variable? In the what?
Domain.
Well, it's in the, yes, it is the domain, but it's in the exponent. Okay, so that's what makes it an exponential function. Your base is a number, your base isn't a variable. That's what's different from what you've seen before with exponents, correct? You've always had. Now, A is greater than 0, obviously, because if it was 0, the number would be 0. And A is also not 1. 1 is not an exponential function. Can anybody think why? Because 1 to any power is what? 1. Okay, exponential growth, as I square a number, cube a number, it's increasing quickly, yes? And so 1 doesn't increase at all. 1 is a constant function. It is not an exponential function. So, not a whole lot to write down there, guys. Okay, so base of A equals 1. I said it's not, and I showed you because 1 to any power is not an exponential function. Just remember that. It's not a huge deal. It's not going to be on the test. It's not going to be, it's just something, is 1 an exponential function? No, because it doesn't increase like exponential functions do. If I graphed 1, it would not look the same as if I graphed 2 to the x. If I graphed 1, it would look like this. Yes? If I graphed 2 to the x, it would look like this. So, that's why it's not an exponential function. Okay. You have evaluated a to the x for integers and rational values of x. You have done that before. We know that 4 cubed is 64. Yes? You should be able to, you should know 4 cubed is 64. And what does this 1/2 mean in the
Half
exponent?
of the 4.
It's the
No,
square root.
it's the square root. That's why we spent 2 days on what we did. It's the square root of 4. The square root of 4 is what? 2. So we've graphed that. So you need to interpret the forms of irrational numbers in that. So take your calculator out real quick, just real quick, and put in 2 to the x, and x is what? What did I say x is? Okay, so you're going to put 2 to the negative 3.1, and tell me what you get.
It's always the graphic part. Like without a calculator.
You're going to graph again.
Is that with color?
What?
Oh, never mind. I thought you had like one of the pencil ones like Mrs. Make
I got approximately 0.1166. How about you guys?
I got yes.
You put a subtraction instead of a negative.
I don't know. Actually, I did not. I tried to put in an X.
Oh.
Well,
That won't work either. And what is this?
3.14.
Nope.
Is that not a pi?
What is it? Pi. That's what I wanted. There's a pi button on your calculator. On your calculator, we will be using pi only. We will not use the decimal approximation. Can anybody find the pi on their calculator?
Yes, right by H.
Dude, my calculator's like at the bottom.
God bless. Right by H.
Bless you.
How about second what?
Second caret.
Caret. So 2 to the caret, and then second caret will give you pi.
Same thing. 8.8.
Dude, I've been looking for this stuff. I got like another bottle of lotion. Thank
Okay.
God.
Ron?
Yeah.
Focus.
Okay. I found my calculator.
Well, by the time you find it, we're going to be off to something else. Okay, so there's a couple problems on your assignment that just say it's like this. So all you're supposed to do is put them in your calculator.
Did I get on
That's
the
it.
ground?
Okay? So you're going to use the caret button, and you're going to put the stuff in the exponent. Make sure if it's a fraction or anything like that, you put parentheses around it, especially if there's something else. Okay? But just be using your calculator, because these are reasonable things to put in your calculator, yes? But if I ask you 2 to the 5th, is that reasonable to put in your calculator? Nope.
Wait, what? Not
2 to the 5th? 2 times 2 is what? 4 times 2 is 8, 2 times 2 is 4, and 4 times 8 is 32, okay? Up to like 2 to the 10th, I would make you do it on your own, okay?
I'd have to write.
I'm gonna
Wait,
go
but
ahead.
hopefully you would know that 2 cubed is 8, right?
Yeah.
So you could start at 8. So if I had 2 to the 6th, well, that's 8 times 8, correct? So it's 64. So some of those things you need to start doing. Make sure in your homework you're doing those kind of things, regrouping them, not always going to your calculator. So, because you won't have a calculator on this test.
I have a question.
What?
Back on that other slide.
Mm-hmm.
Did that negative x not matter in the function thing? Is that a negative x?
Oh, I didn't look there. Yes, I didn't look that it was negative. Okay, so we need to go back and redo it, right? Means 2 to the negative pi.
Yeah.
And make sure you put a negative and not a subtraction. 0.113.
Good
3.
catch.
Now, this was 2 to the negative pi, correct?
Yep.
And this was just 2 to the pi. So there is a difference. Remember, the negative exponent reciprocates it, correct? So this is really 1 over 2 to the pi.
Wow.
Okay? So that means if I put 1 over this, if I put 1 over this, I should get this answer. Try it. My calculator, try it.
Wait, what?
Since this is 1 over 2 to the pi, if I take 2 to the pi and put 1,
Oh, you do.
I got it.
you get what you're supposed to get, right?
That's cool.
And you get that.
The more you know.
So that negative exponent reciprocates it. It doesn't do anything to the actual positive or negative of the number. Okay. In the same coordinate plane, use your graphing calculator to graph x, 2 to the x, 4 to the x, 8 to the x, 15 to the x. So on your graphing calculator, 2, 4, 8, 15, right? Go, how do I graph?
Okay, graph. Y.
I hit y equals. So we had 2 to the x, right?
Ting. That's
And
what
then
it says.
4 to the x. What was the other one? 6? 8? And then 15, right?
Yeah.
Okay. So what do you think, before I hit graph, what do you think's going to happen?
They're gonna go.
They're going to go up, right? Exponential growth happens quick. What do you think's going to go quicker?
The 8 to the 15.
The 8 to the 15.
They're just-
We don't have an 8 to the 15.
As in, like,
Like 8x.
Oh, and okay. I was like, when you said that, I'm like, we don't have that. Okay, I had a different screen on mine, so I had to do that.
the first
Am I still thinking?
one.
I might have to tap it a little.
No, if you tap it, you paused it.
What?
If you hit enter more than once, you paused it.
Oh.
So you.
Which
Oh,
one?
no, yes. No, sorry.
Okay. Now, we're kind of like squished up in there a little bit.
Why are there?
So first of all, I'm going to go change a color here. Oh,
I
shoot.
have a lot on mine. Yeah, I have a lot on mine. 4? Yeah, 4. Perfect.
And I'm also going to change my window because I don't care. All the negatives, they were just little amounts, right? Actually, I'm just going to change my y's because none of them went below the x-axis, did they? Now, this is where it comes into play down here. It's never 0, guys. It is never 0 because as I take x to a negative power, that gives it smaller and smaller, right? Like 2 to the negative 20, that's 1 over 2 to the 20th. Really small number, but is it 0? No. Okay, so which one's which?
The
15
red
is
one is the first one.
orange is 15.
The orange is 15 to the x. Then the 8 is, the black one is 8 to the x. And then 4 to the x is green, and the magenta is 2 to the x. Why is it getting closer and closer and closer to the y-axis?
Because it doesn't hit 0.
It doesn't hit 0. But what's happening to my base?
It's getting bigger, so
Okay,
it goes
it's-
up faster.
Right. So as my base, remember we talked about A?
Yeah.
My base is my A, isn't it? And as my A is a larger number, it's a narrower graph, isn't it? So this is narrower in respect to the y-axis. So as my base gets bigger, it's going to get closer and closer to the y-axis. What happens if my base is a half?
Then it'll get.
It's going to
even-
get further away. It'd be on the opposite side, right? And if my base was like 1/28, it would go really, really wide before it started to go up, right? But would it essentially have the same shape over time?
Yeah.
Yes, I'd have to like zoom clear out to see the same shape, but it would eventually have the same shape. Yes.
When I went to change my y's to 0, like you did, it did me
When you went to window
in there. Yeah.
and you put your minimum at 0?
Yeah.
Did you
but-
put both of 'em?
Oh, that's why.
Yeah, you can't have both min and max at 0. That won't work. Okay, so
Look at that.
you can see that behavior, right? What do you also notice about every single one of these graphs?
They hit the 1.
They hit the 1. So it's y is 1, that means x was what? What's the x right here? 0. Okay, what do you know about anything to the 0 power?
It's 0.
No,
It's nothing.
it's 1.
1.
Talked about this.
Yeah, I got it.
Anything to the 0 power is 1, yes? So is every single exponential graph, before I move it right, left, up, down, going to go through 0, 1? Yes.
For all of our graphs, they're gonna look like that.
Well, no, because we're going to move them left, right, up, down.
Don't do.
Okay, so I'm going to go back here.
Don't do. I thought I had.
And we already did this, what we noticed about it, so. So here is the parent function of an exponential function. It's zoomed in, but it just shoots up, right? If I would continue to do this, I would go up. Go up. So let's see. Well, domain would be all real numbers, correct? I could put anything I wanted in there. The range is real numbers greater than 0, because I can't make it 0 with a negative exponent. What does a negative exponent do? It doesn't make it go negative, it makes it reciprocate, doesn't it? It makes it a smaller number. So the only way I can make it negative is to make my base negative, and we're just talking about the parent function. Again, the parent function, a is greater than 1. Okay, the y-intercept is 1. Why is the y-intercept 1?
Because
Anything to the 0 power is what? 1. You can't remember that, write it on there. Anything to the 0 power is 1. So when we graph these things, we will be writing 0, 1 goes to, remember when we were graphing all the others, we did 0, 0 went to, that was our anchor point, our vertex. But here, what's our vertex anchor point going to be? 0, 1. So we're going to talk always about what happens to 0, 1. It's increasing, obviously. And the x-axis is a horizontal asymptote. And it is a continuous function. So-
anything to the 0 power is 0, 1. So
Well, anything to the 0 power, which would be your x, is 1. The y is 1.
So all of them will have that intercept, the y-intercept.
Well, until we move it left, right, up, down.
Oh, right.
But the parent function always goes through 0, 1. So before, remember, we moved 0, 0, and we added or subtracted x's and h's and all that. But now we're not going to go 0, 1. We're going to go what? We're not going to go 0, 0. We're going to go 0, 1. So you guys can draw me a quadratic, a cubic. Now you can draw me an exponential. It does what?
increase.
Am I good? Okay. So what did I do here?
Decreased.
How? This is a decay function. It says how?
Because it's a negative.
It's a negative what?
X.
Exponent. Okay? So a negative exponent is going to make my numbers not bigger, but smaller. But it, again, domain is negative infinity, positive infinity. Range is 0 to positive infinity. The y-intercept is still 0, 1, but it's not increasing, it is what? Decreasing. And the x-axis is still my horizontal asymptote, and it is still continuous. They use decay models when they talk about like elements and chemicals. They have exponential decay. Or we'll talk about some radioactive isotopes. So exactly the same as the increasing, but it's what? Decreasing. And what made it decrease?
The negative exponent.
The negative exponent. Let me know when you're good, guys.
Oh, I'm good.
So your
Wrong.
range is always gonna be 0, positive infinity.
Until we move it up and down. If we moved it down, then wherever we moved it down to would be my lowest point. If I moved it up, that would be my lowest point.
What do you mean move it down?
Like if we have a K, the K moves up and down. Okay, and we're gonna do K's here.
Okay, but I have a question. Like, how do we know that the point is on 0? Because technically, wouldn't it be on 1 there? Like, I know it's 0, 1, but like your point is at 1.
No, that's the point, but the graph is decreasing to the horizontal asymptote.
Which is 0. Oh,
Okay, so we're gonna graph these three, and actually I have it right here. I just wanted you to see, and I don't know why I did that. I know why I did that. Okay, so this is 3 to the x, right here. Yes? Okay, and I could get 3 to the x by plugging in 3 to the first, the second, the third, the fourth, the fifth, right? I don't care what it looks like. All I care about is if I had to graph on the same graph 3 to the x and 10 to the x, which one would be closer to the y-axis? 10 to the x. That's what I care about, okay? So, why did this graph go down like this?
Okay. Oh, negative.
It has a negative a, doesn't it?
Right.
When I have a negative a, it reflects over the x-axis. Same as before, didn't it? Okay? So now this one is 3 to the negative x. Well, here's 3 to the x, yes? And that's a growth function. And now I have a decay function. Guys, what does a negative x do to my graph? It reflects it over what axis?
The x-axis.
Not the x,
The
the y.
y-axis.
Is that the same as before? The same thing as when I taught you guys this in chapter 1, when we did parent functions and behaviors, right? So a negative base is going to reflect it over the x-axis. A negative x is going to reflect it over the y-axis.
Wait, so then why are there two rows?
What?
Oh, never mind.
So a negative exponent
One's
is
a
over
positive
the y.
x.
Yes, because the negative is on the x value, just like when we did the other parent functions. And I keep saying just like we did because it is. I promised you I would tell you exactly in the same way, and I am. 3 is my A. So if I wanted to come back here and write this parent function like I've seen every time before, it would be plus or minus A of x to the negative h plus k. What's h do to this?
Makes it bigger.
No, what's h?
H is x.
H is the left or right, the horizontal movement, yes? K is the what?
Up and down.
Up and down movement. This x actually has a plus or a minus on it. If it's plus, it's growth, right? If it's minus, it's decay. And out here, that's reflection over the x-axis. Everything still plays the same role. But what are we doing? We're doing a different shape with the same role. Does that make sense? So we're not moving 0, 0 anymore, we're moving what?
0, 0,
0, 1. Okay, since the graph passes through the horizontal line, test, it is a function, and it also is a one-to-one function. So this right here, I'll show you. This is great. This is how you graph one of these. That's it. That's a 1. I pinned that. That's it. That's how I graph. That's my shape, right? So it passes the vertical line test, yes? Does it pass the horizontal line test? Yes. So it's 1-to-1, so that tells you that it does, its inverse is also a function. And we have this property, it's the 1-to-1 property, it's amazing. When a function is 1-to-1, you can use this property always. I say it's a property just because it's one of those things like, oh, I should know that. If the bases are the same, then what has to be the same? The exponents. If the bases are the same, the exponents have to be the same. So could I use that to solve things? Yeah. So if I had 6 to the x plus 7 equaled 6 to the 20th, bases are the same, yes? So what does it have to be the same? The exponents. So all I do is just put x plus 7 equals 20, subtract 7, so x equals 13. So the 1-to-1 property is the easiest property to use in any of these functions that we will be introducing over the next while, but it's also the one we tend to forget about. So don't forget about it, okay? If the bases are equal, what's equal?
Yes.
The exponents. Okay, so 9 equals 3x to the x plus 1. Okay, my bases are not equal, are they?
No.
But can I make them equal?
Yeah.
Can I make 3 and 9 be 3? Yeah. What is
3 squared.
3 squared?
3 squared.
So I can make it 3 squared equals 3x plus 1.
Or let me start my pose first.
Let me
So I
put
have
mine
3 squared equals 3x plus 1. So are my bases equal now? So now I can do what?
down. Have some.
I
Solve
can
for x.
I can
X
solve
is
for x. So 2 equals x plus 1. So what's x equal?
1.
Give this back to
Will you give me a dab?
No.
Hit the wall.
Okay, we got 2 and 8.
You can
2 times 2 times 2, so 2 to the third, right?
Wait, where did you get 2?
Well, I have a 2 here. I'd rather make 8 2 than 2 8, wouldn't you?
Oh, yeah.
Yeah?
I forgot, like, 1 over 2.
Okay, so we have 2 cubed, yes?
Yeah.
Okay. Well, that still isn't 2, it's 1/2. So how can I make 1/2 2?
2, 4,
You divide it by...
I can't, whatever I do, like if I multiply by something, I'm just rewriting it. This part does not exist. Okay, I can't just multiply it and make it by. What can I manipulate? I have an exponent.
2 times 1. What?
You can make that exponent 8.
You make it negative.
What about it negative?
It's a flop.
If I make that exponent negative, what does it do to this whole thing?
Flip
So if I have 2 over 1 to the,
Negative x.
no,
negative 3.
no, I wanted to do this. Okay, 2 to the negative x, is that really just 1/2?
Yeah.
Yes. So I can change it up. I'm manipulating them, but I can't like change the number. Like I can't multiply it by times 4. Because if I multiplied the left times 4, then I'd have to multiply the right times 4, and they're not equal anymore, are they? So watch out doing that kind of stuff. But I just rewrote it. I didn't change it in any way. I just wrote it in a different way. So now my bases are equal, yes?
Yeah.
So what's equal now?
That's all it is.
So negative x equals 3,
plus 1,
not plus 1,
divide.
times by -1 or divide by -1, but you can't plus 1 because it's multiplication. So x equals what?
-3.
-3. Now, can I check my answer? Let's plug it in. I have 1/2 to the -3rd. Well, what's the negative going to do to it? It's going to reciprocate it. So it would be 2 to the 3rd, and 2 to the 3rd is 8. Okay, I have 16 and 2. I'm looking at my two bases. Am I going to make 2 16 or am I going to make 16 2?
16.
Okay, I could make 2 16 by telling you it was like the 5th root. Would you like to do the 5th root? Actually, give you the 4th root. Sorry. I don't want to add in the 4th root in there, do you? So usually try to make the bigger number the smaller number. So 2 to what power is 16? 2 2 is 4, yes. 4 and 4 is 16. So what power? 4. So with, especially with your 2s and 3s, try to make those pairs, guys. Don't just go 2 times 2 times 2 times 2, you know, because that could take forever. So exponents are equal, so now what? I mean, bases are equal, so
4 equals x plus 2.
So 4 equals x plus 2. So subtract 2 and x equals 2. Does it work? 2 to the 2 plus 2 is 2 to the 4, which is 16. Okay, 3 and 81. I would do everything possible to go to 3, right? So 3 times 3 is what?
9.
And 9 squared is 81. So it'd be 3 to the what? 4. And then what do I have to do with this fraction over here?
Negative.
Make it a negative.
So it's
Now-
negative x.
So it's 3 to the negative x. And so negative x equals 4. So x equals -4. Now, in past years, I have had people that do this. There's nothing wrong with it. I'm going to show you what they do. They do the 3 to the 4th, but then they will go 1 over 3 to the x equals 1/3 to the -4.
That looks like something I would do.
Okay, there's nothing wrong with that. Because I know 81, and it comes from here. I know 81 is 3 to the 4th, yes? But I need it to be 1/3, right? I need 1/3 to be 3 or 3 to be 1/3. So they just make this 3 the 1/3. Am I getting the same answer?
Yep.
So either one is fine.
So when we write it, we're writing 3 to the -4 equals 3 to the 4. Not 1/3 to the -4 equals 81. I'm so confused.
There's two different methods to do it. We initially made everything 3. So we had 3 to the 4th, and then we took the negative exponent to reciprocate the 1/3.
Oh, never mind.
Are you good now? Okay, the other way you could do it is start with the 3 to the 4th and make it 1/3, so it would be -4. Either method is fine. But you have to have the same base. You can't have 3 and 1/3 and do this. It will not work. Got it? So let's check our answer. So I have 1 over 3 to the -4th. So then you would have 1 over 81, which would be, oh, to the negative first, sorry. Not my negative. Would be 81, correct?
Yep.
Now, if I did this, let's say I took this and I made it, you would tell me x was what? 4? If I didn't have it the same? Well, if x was the 4th, I would get 1 over 81, not 81. And there's a big difference between $81 and 1/81st of a dollar, correct? Okay. Okay, now what did I add in?
Negative.
Oh, actually, like
Okay.
K and then H, right? Some H's and some K's? Okay, so this one is the parent function. It's going to go through 0, 1, yes?
Yep.
Okay, we know that. Well, what is this? Nature or K?
Okay.
Wait, what'd you say?
What's the 1? It's an H. How do I know it's an H?
Oh, because it's not outside of the
Right.
exponent.
Now, the other way, when you see the book, they're going to write it like this. This is how I would suggest you write this. Did I make my brain see that as an H now? Yes. Is that important to do?
Yep.
Okay, remember H's are always the opposite direction, yes? So it's not moving one to the right, it's moving one to the left. So I'm going to have 0, 1 is going to go to what?
0 or -1.
Negative 1, 1. My domain's not changing, right? My range, it didn't go up or down, did it? So it's not changing. So if I look down here, right here is my, here is my 3 to the x, right? And now this 0, 1 went to -1, 1. And then you have your, how did they find their y-intercept? How do I find y-intercept on any, set it equal to 0, right? So I would have 0 equaled 3 to the x plus 1. And I need to do a 1-to-1 property, right? What power of 3 gives you 0?
1.
Wait.
0.
Wait. Oh, I did that. I'm finding the x-intercept. There is no x-intercept. And Katie said right, and I didn't do it. Sorry. So it's going to be y equals 3. She said 0 for x, and I put it for y. Okay. To find a y-intercept, I put a 0 for x, yes? I said that wrong. Okay, so 0 plus 1 is 1, and you get 3. So your y-intercept is 3. I was finding the x-intercept. Oh, well, okay, so I was finding the x-intercept, guys, right here. And the reason why I stopped is there any power of 3 that can give you 0? No. So there is no x-intercept. That's why. There's no power of 3 that can give me 0. So there is no x-intercept. Okay, so now, right here, is that 2 an H or a K? It's a K. So 0, 1 is going to go to what?
0, -1.
0, negative 2.
0.
Positive 2.
Negative
I'm going to subtract 2. So it would be -1.
Because you have 0 and then negative.
Yes. Okay, so here's my parent function right here. And I need to figure out some other stuff. Because I know it goes through 0, -1. So it comes through here. But if I moved everything down 2, does that mean I move my vertical asymptote down 2 also? Okay, so my vertical asymptote was x equaled 0, yes? Now it is going to be x equals what?
-2.
-2. Because everything is moving down. Now I'm going to have an x-intercept. Yeah, because I'm moving below the x-axis, correct? So x-intercept, I plug 0 in for y, so I have 0 equals, oh, better label my work, right? So 0 equals 3x minus 2. Now that minus 2 is out of the exponent, isn't it? So I can move it over. So I would add 2 to both sides. So I have 2 equals 3x. And there is a power of 3 that could give us 2, but I don't know what it is. It's actually log base 3 of 2, which is not something I know what it is, even if I tell you that. Okay? But did I find the x-intercept? Like this would be how I would find it. And when we do logarithms, you'll go and say x equals log base 3 of 2.
I
And
had so many of those questions on the ACT.
did you?
And I had no clue what to do. So
Hopefully you put them in your calculator.
yeah.
No.
I didn't.
Okay, so we have this, and so we would be able to put that into a calculator and find the approximate answer. Okay, so now we need y-intercept. How do I find a y-intercept? Put in 0 for x. So that gives me 3 to the 0 minus 2. Well, 3 to the 0 is what? 1 minus 2. So the y-intercept would be -1. So 0, -1. Which, did we already have the y-intercept is 0, -1? But algebraically, I found it.
What the heck did you use?
We found it. I don't know. The pen is like jumping everywhere. Must not have picked up. So we calculated the y-intercept when we actually just used the y-intercept off of our knowledge, right? So we moved the horizontal asymptote down to -2. We know we go through here, and I'm gonna tell you it's probably the power of 3 that gives you 2 is definitely going to be less than 1, isn't it? Because 3 to the first is what? 3. So we know we're gonna cross somewhere between 0 and 1. So you would just go up like that. Main things I'm concerned about, guys, horizontal asymptote, and where does that 0, 1 go? Okay.
Whack. Oh, I thought we were done.
E. E is a number. If you have your calculator still out, look for the E button. There's 2 of them. Divided by is E. And if you look, there's an LN button. It's natural log. It's 3 up from the bottom. It's, do you see it?
Yeah.
Okay, that is e to the x. So the e to the x, oh, I'm not open. There it is. Okay, so right here is e to the x. It's the exponent, but you always can use e and just use the caret. Okay? So just so you know, I would like you to put e in your calculator. So if you I'm just going to use the division one, and I'm just going to put e. If I don't put any power, the power is 1, correct? 2.718281828182818281828. It is a number. E is a symbol for a number, okay? Just like pi is a symbol for a number. E is not a variable. That is why we never use e as a variable for things. It is a symbol that we use for a number. We will never use 2.71828, but you need to know that e is approximately 2.7. You need to know that because it's important not to get to 3 if I'm using it, right? So there is no difference between it. If I'm telling you e is a number, is everything, the h, the k, everything else going to be the same? Yes. It's a number. They talk about it like it's a special exponential function, but it's not because, I'm trying to get the notebook to come back up. It's not anything special. E is called the natural base, and I remind people of things because you do need to know that E is the natural base. Think about things that are natural, like they say all natural shampoo or whatever. What does it come from? The earth. Earth starts with what? E. Okay, so you can use that as kind of a mnemonic device to remember that the natural base is E. Look at my graph. Does it look exactly like the other graph? Yes, it's just a number. And we call the graph the natural exponential function. Makes sense, doesn't it? If it's the natural base, it's the natural exponential function. Everything is going to work the same. There's the 1-to-1 works the same. Everything. In your calculator, they're going to have a couple of problems for you to use your calculator. Just put it in your calculator and get out the answer, okay? But domain is still all real numbers. Range is everything greater than 0. The y-intercept is still what? 0, 1. Everything is the same. Got it?
Yes.
Yes. Let's see what my next slide is. But if you want to try to put those in your calculator, you can real quick. I wanted to get, yep, that's it. Everything else is the same. Everything. I'm stressing that. It's big time. Everything is the same. The 1-to-1 property is everything. Okay? And you can't make something be E, so it's either E or not E.